Yeah, so today I just wanted to highlight one of the tools that we build for CosmWasm scripting, testing, and deployments. It is called CW-Orchestrator, and this is an environment-agnostic tool. And what this means is that you can write your test in your unit tests in CW multitest. You can write your integration tests using TestTube by osmosis. You can write your IBC tests using Starship. And you can write scripts, for live networks like Archway, mainnet, which I will do a demonstration near the completion of this call, all in Rust and which is native to CosmWasm, of course. So you can find the GitHub link here at abstract_SDK/CW-Orchestrator, and I will go ahead and go over what this product is about, I suppose. So, yes. For some background, when you're interacting with CosmWasm, there are essentially only a few actions that you can do. So you can execute on a contract, you can query on a contract, and to make that contract real, you instantiate it. There's also a few other entry points related to IBC, that CW-Orchestrator also supports. So at its most basic, when you're a contract dev, you need to know that there are a few actions that you take on your contracts, which is calling an entry point. So these are generally on-chain interactions, and so when you're interacting with a live contract, you have to take the struct definition, which would be in this case, an instantiate message. You would transform this into JSON, and you would send this over to the Cosmos SDK node to execute that transaction on a chain. And so, for the most part, this is done through the CLI or through a front end, like some of the tooling that we have on the Abstract Developer Console, or teams would typically use Python or JavaScript scripts. And I think this is actually a practice that carried over from the EVM ecosystem, as you cannot write scripts in Solidity. So most dev teams resort to using TypeScript or Python to enable interactions with their contracts as well as testing. And now in CosmWasm, we're actually blessed with Rust. And so we can use the same language to interact with our smart contracts in which we write with our smart contracts. And that is one of the biggest benefits of using CW-Orchestrator versus other tools that may be available. So in CosmWasm, there are a few ways that we can test our contracts. Generally, you unit test using CW multitest, which is a mock environment. And so this mock environment essentially takes everything that would happen in the WasmD VM, and it just stubs the execution and simulates those operations. Or you can use TestTube, which actually uses the Go binary and runs some of your code against that Go binary. And something that's really difficult, as we've seen in using multiple different tools or multiple different libraries, is that all of them have completely different syntax. So over here on the right, you can actually see we're building a factory message. We're creating a pair on, and I believe in this example, it is Astroport. And taking a mock app object, we call execute contract. We give the sender and then the address of the contract we want to execute as well as the message. And then if we want to query it using, in this case, CW multitest, you do the same thing. And you call query wasm smart given the instance of that, given that contract address. And of course, when you're using TestTube, this looks a bit different. So I now want to show how CosmWasm interactions are done typically in TypeScript, or in this case, JavaScript. These are on the left, we have the Astroport deployment scripts. You can see they're in TypeScript, and on the right we have some examples in Rust. And the reason I want to bring this up is one of the biggest limitations to using a different language in testing your contracts and in writing them is that when you change your contracts, when you manipulate that contract code, your test may not break. And as dev, you may be on the surface level, you'll be like, well, actually, I wouldn't want my tests to break because, that's annoying. I have to go and fix them. But the entire point of tests is that when you change your contract, your tests can assert that the contract's validity and the execution's validity. And it's a much worse developer process when your tests are running and they compile, but you don't, while you've changed your contracts, you can't test the new code very well. And so we also lose all of the type safety benefits brought to us by Rust. And so in the right, we have an example of instantiating 2 tokens and creating a pair on Astroport completely in Rust. And this is done using CW multitest. So developers don't have to switch environments, and they can use the native language for their contracts in testing their contracts. Yes, and we unify CosmWasm interactions in any environment. So I'm going to get a little bit more technical here, and go over some of the details behind how this works. So at the very base of using CW-Orchestrator, you have one struct that represents your contract. And in this instance, we have a struct called proxy, and then a generic argument called chain. And so this proxy represents our contract, and you can see this macro declared above the contract where we say we import CW-Orchestrator interface, and we give it the instantiate, execute, query, and migrate message, all of the entry points to your contract. And this does some magic behind the scenes, and it implements some methods on this struct so that you can interact with your contracts through an instance of this struct. And here's some of this magic that it does for you. We also allow the developers to override this if they please. So we can see implementation of the uploadable trait for this struct. And so the first one is declaring a wrapper. And this may sound familiar. This dying contract may feel familiar for those that have used CW multitest. It is essentially a mock interface for your contract that you pass in all of your entry point handler functions to, so that the mock environment can run that code in the background. The second one is for live environments, where you actually give the path where the contract WASM would be stored. And this allows you to upload and store contracts on live environments. So one of the second biggest advantages to using Rust is that you can actually compose different contract interfaces over different environments. And so you can see here, this is an instance of an abstract account. And an abstract account is actually composed of 2 contracts, the manager and the proxy. So we have a struct on the top that represents both these contracts together, and then we can implement methods on this abstract account. In this case, that we have implemented the upload function, which calls the upload functions of each of the members. And this allows us to define interfaces for our contracts that we can use in our tests and our deployment scripts that we can also publish and allow other teams to use or take a dependency on and integrate with our contracts much more easily. It also allows you to encapsulate a lot of the functionality, like the more advanced functionality in your contracts. For example, if you're building or if you're using the abstract account, we have a means of installing modules, but you can add a helper method that installs the module on that account and retrieves the address of the module afterwards. And this hides the complexity of your contract interfaces. So now I just want to show the usage of the entry points when you're using CW-Orchestrator, and I'll reiterate that these same methods are used across any environment. So when you're writing your unit tests or your live deployment scripts, you can just call upload and instantiate, and it'll work just the same. So in this example, we create a new instance of our struct right here. We can see that we're creating a new counter contract. We're passing in the name of the contract and then the instance of the chain that we're using. And in this case, this instance is the mock environment, which is a struct that implements the appropriate methods for an environment. So you can see then we call upload, and then we instantiate and execute execute, and query the contract with traditional syntax. You can see that we pass in the instantiate message and the execute message explicitly. And in this case, the execute message has a funds argument, which you can see that we're passing none. And this is fine and dandy, like whoopity-doo. It's very cool, but we have some much more powerful helpers within CW-Orchestrator that makes your life as a dev easier. So optionally, when you use CW-Orchestrator, you can include a derive execute functions macro above your execute and your query message. Of course, with query message, it would be query functions, but this does even more magic behind the scenes. And yes, so remember in the previous example, we did .execute, we passed in the execute message increment, and then the funds none. And you can see here, with this macro, we can actually call increment on the contract instance directly without having to build the execute message ourselves. And so now we've called the same function in maybe 8 characters instead of 20, and in this instance, it doesn't save that much text, but it certainly makes it more readable and easier to use in the long run. And this works with the query messages as well. We're calling getCount, and the return type for that query message is actually strongly typed. So we declare it here, but this return type is strongly typed, and it knows about the return type for that function, which means that you as a dev have a much more easy way of interacting with the contracts. So yes, as I mentioned previously, CW-Orchestrator is environment agnostic, which is this generic on the struct representing your contract, and we support the following environments. And I will make an amendment to this slide. Instead of interchain test, we actually support an IBC testing tool called Starship, made by the cosmology team. And on this third line, you may see that there's a hybrid environment. And so this highlights one of the additional features of CW-Orchestrator is fork testing. And so I'm not going to dive too deep into this right now, but anyone who has done any development in the EVM ecosystem knows that tools such as Hardhat and Foundry support something called fork testing, where you specify a block and any queries of state can get forwarded to the live nodes until it hits that block, and then they would get the result of that query would be subject to the local state. And this means that if you're Astro Vault and you're looking to upgrade your pools, you can actually tell the CW-Orchestrator to fork the current state and upgrade the pools in your local testing environment and simulate what's going to happen to the liquidity. And this means that you're going to provide a much safer experience for your users, because you can check your upgrades and your bug fixes against the live state with real data. Because as many of us know, adding fake data into your contracts sucks, and we can't think of all the edge cases. So this just allows you to cover all of them. Yep, and the last thing that we're trying to build is support any WASM environment. And so other ecosystems, such as the Avalanche ecosystem and the Polkadot ecosystem, both have WASM-D environments supporting CosmWasm. And this means that you can actually use your CW-Orchestrator scripts, the same ones that you use to test and interact with your contracts, to deploy on other ecosystems than Cosmos, which, as far as I know, is not possible right now without usage of external tools. So I'd like to show some of the usage of the mock environment using CW multitest. So the first thing that you do is you declare the sender for your executions. You instantiate the mock environment, and then you declare your contract, which is strongly typed and supports the mock environment. When you want to interact with the live daemon, which we will do shortly when we are doing the demonstration, you can actually, you build the daemon and you tell it which chain that you want to use. In the slides, we are using local Juno. Of course, this supports testnets and mainnets just the same as they are just Cosmos SDK nodes. You give it some mnemonic that you want to use as the deployment mnemonic or the interaction mnemonic. And then you have an instance of this daemon, and as you can see, you actually interact with it just the same as you would the mock environment. When you're using TestTube, it's the same story. And yeah, I just wanted to highlight a new feature that we have in CW-Orchestrator now, which is when you are publishing an interface for your contracts. Like if you are Astrovault and you are looking to have other protocols integrate with Astrovault, you can publish in your CW-Orchestrator crate your interfaces for your contracts, keep your contracts completely closed source, but you can publish it alongside the WASMs as well as addresses in your testnet or your mainnet environments, which means that when other teams go to interact with your contracts, they can have all of Astrovault deployed directly on their test environment, on their testnet environment, or even their local node with ease. And so this makes it much more portable and allows us as CosmWasm teams to collaborate more, which is what's going to take us beyond the applications of the EVM ecosystem. So this is an example of this in use for the abstract framework. So you can see in one line we are retrieving a struct representing all of abstract using the load from trait. And this will legitimately reach out to the chain, get all of the, it'll reach out to this daemon's state that you can see here and retrieve all of the addresses for the given environment and be able to interact with it directly. So yeah, if you want to learn more, you can check out our documentation at orchestrator.abstract.money or our GitHub repo on the Abstract SDK org. And so I'm going to open it up for questions right now, and then I can hop into a live demo. If not, then cool. So I'll go ahead and enter presentation mode in my IDE. And I can showcase some of the functionality that I was talking about in the presentation. So the first one is I just wanted to highlight the usage of the trait that we support that allows you to get the execute functions. So as you can see here on line 30, we're just calling the execute increment as normal. And then let's say that I wanted to call it the new way, then I can actually just do .increment. And as you can see, the IDE pops up the suggestion. It knows about it, so you get wonderful auto-completion on your contracts. And so, yes, and you can see here, we have declared the struct for the counter contract that represents it, and that we've implemented the uploadable trait for this contract. This, of course, would be the WASM path for the contract in live environments. We can also return a mock wrapper for that contract. Something else that I wanted to show down here is that when you have this struct representing your contract, you can implement methods on it and extend the functionality. So this await launch function is a sync means of it allows you to just upload the contract and instantiate it and wait for it to be deployed to that live environment. And the process is very similar for test tube. And so if I test tube, osmosis test tube, you instantiate the environment, and you can use while the setup of the environment is a little bit different, you can see here that we have to init an account on the environment. Usage of the contract is the same. We also support a lot of helper methods that make your time as developer easier, such as call as. So you can change the sender in the contract from the one that's declared on the environment. Or you can set it declaratively, I suppose. Yes, and of course, like some of these custom environments have custom methods declared on them, such as in Osmosis Test Tube, you are able to increase the time or the block height, so on and so forth. And so I can go ahead and run one of these. It's not going to be very exciting because there's no output. However, I will do a live deployment of Abstract Infrastructure, Abstract's latest version, on Archway mainnet. So that should be relatively exciting. And of course, like I rode this method right here, which incremented it twice. But if we just call .unwrap and we do it here, you can see that it works the same either way, and it passes. Yeah, and so now I will go ahead and run you through the abstract deployment script. So this is a relatively typical script. We actually have used something called the just file, and in this just file we have a method called deploy, which runs scripts full deploy, and we pass in the chains as an argument. And you can see here we parse the arguments giving the network IDs. So if we were to run this, we would call frameworks/scripts, and we do just deploy, and instead of Constantine, we will do Archway 1, and I'll go ahead and leave that down there for now. So first thing we do is we parse the networks, and we get a strongly typed chain info struct representing these networks, and this has some information that's used by the runtime. And so here, given the networks, we check the wallet balance on each of these networks. On Archway, this tends to be a bit higher due to the fee split module. And we can iterate through these networks and build the chain, the daemon struct for that, which is a live environment. And then we can just call essentially one line, which is abstract deploy on. And in this one line, we deploy maybe 6 or 7 different contracts to the target environment. And so this abstract struct is something that we also publish. You're able to deploy this on your test environments if you want to integrate with abstract, as well as any testnet or live environment. And you can see down here after we deploy all of abstract, which instantiates all the infrastructure, we just create a default account. So I'll go ahead and demo this, and if we have enough gas, which I'm pretty confident we do, then we will see it working. So yeah, as you can see here, we don't have enough gas because we just don't. So that's awesome. I will see about sending some gas. Actually, unless anyone, what we can do is, I think, yeah, I'm trying to deploy the Archway mainnet, yeah. Yes, Adrian. Thank you, sir. Live demo problems. I thought I had enough gas. What I can do in the meantime is show you a little example of interacting with custom modules on the chain. So if we look in the CW-Orchestrator repo and do querier examples, bank query. Well, this is not necessarily a custom module, but we have a very standard way of using of declaring interfaces structs that can represent that custom module. And so here we have a bank struct that allows you to perform queries on that Cosmos SDK module. So you can see down here, we're using this bank query client and we're calling balance, and this hides all the complexity from you as the user. If you wanted to do a, what's it called? If you wanted to query another one, for example, fee grant, you can see it's the same querier, and you can just call bank query client.allowance, for example, and you can pass in whatever parameters that you want. And of course, this is an async function, but we also have sync queriers available. Yes. All right. Thank you so much, Adrian. And this is like one of the cool things that you can do. So like, you can see here, we checked that we had enough funds. And the reason that we added this is because we would go and deploy on a network and we'd be midway through the deployment and we would run out of gas, which is relatively unfortunate. But yes, let's go ahead and run this. And as it's running, I can propagate it from the chain. So, yes. Oh, wait. What are you asking? I don't know. So we can dive deeper into that after the call if you'd like. But yeah, so thank you, Adrian, for the testnet tokens. As you can see here, the script is running, and it is first it's uploading each of the contracts. You can see that they were uploaded with various code IDs. Now we're going ahead and instantiating the abstract name service host. We get the address for that. We're instantiating version control, giving it the admin and the instantiate message. Then the module factory, which allows for instantiating multiple different modules. The account factory, which builds abstract accounts and lets you interact with those abstract accounts. Or not interact, but it builds, yeah, it creates accounts. Then we execute propose modules on version control. We're adding the abstract account modules, so the manager, the proxy, ANS host, version control, and the module factory itself. And then we create the first account on Archway testnet with the name default abstract account.